but you could drive your MOSFETs with the push-pull circuit. Okay, very simple circuit. When you have a simple inverter, you can drive using a push-pull part. But normally, I prefer to use off-the-shelf drivers, which have got a very high amp capability of driving the gate. For example, this one here is a high side driver. Okay, so high side driver actually has got both low side and high side driver, right? So you have two signals coming in from your microcontroller, input and low input and high input, all right? And this driver will issue pulses to the lower MOSFET and also issue pulses to the higher MOSFET. Now, higher MOSFET, we use a concept called bootstrap capacitor. And the whole idea of the bootstrap capacitor is it is going to supply the voltage to the gate drive, and the gate is going to float with the load. Okay, so this point also floats with the load. And as a result, you're still able to have positive gate signal between the gate and the source. Okay, so that's the whole idea behind the bootstrap capacitor. Now, the bootstrap capacitor is a critical part, which we're going to discuss here in a few in upcoming slides. So, what is the function of the MOSFET driver? The MOSFET driver has to faithfully apply pulses of exact voltage and time period, avoid misfiring of the MOSFET.
Sir,
Yes.
Yeah. With bootstrap strategy, we cannot, however, go to 100% duty cycle. No.
Correct. Yes, you cannot go to 100% duty cycle.
Like, is there any instance where you have like seen where we go for 100% duty cycle in motor control?
No, you cannot with the bootstrap. So that's a good point.
No, not with the bootstrap, but in terms of like motor control, is there any instance like where we are forced to go to 100% duty? So maybe we'll then not use bootstrap.
No, we so 100% duty cycle is not really possible. Okay. The reason it's not possible is because you are always going to have, 100% duty cycle means that your top
deadband.
Sorry?
Yeah, deadband has to also be there. So
yes. Deadband has to be there, and then you cannot modulate your voltage with the 100% duty cycle. So you always have to have some kind of a deadband, which also helps to charge your bootstrap. But that's a good question. That's a very good question in terms of thinking about the duty cycle.
Does the bootstrap capacitor is charged when there is the dead time? I believe it is going to be charged when you have the low input, the low MOSFET on.
Yeah, that's a very good point. I think that's also a good point there, Constantino. So let's drive that. I think so. When does the bootstrap capacitor get charged, right? So let's think about that for a second here. So let me go back to the circuit here and let me share my screen again. Okay, so when we have the bootstrap capacitor, so I have got the top MOSFET here, and I have got the bottom MOSFET here, okay? And then I have got a bootstrap sitting here at this point. And this bootstrap capacitor is being charged from a VDD, a resistor, and a diode to the cylinder source. Okay, so so this capacitor gets charged through this circuit here.